I want to find the derivative of f of x equals natural log of x using the limit definition. So I want to find the limit as h approaches 0 of f of x plus h minus f of x all over h. For f of x plus h, I'm going to replace x with x plus h. And f of x is what we started with, all over h. Whenever I have two natural logs, or two logs with the same base, and I'm subtracting them, I always divide the inside. So in this case, ln of a minus ln of b is going to be ln of a over b. So let's do that for x plus h and x. I'm going to be dividing those two. And x plus h over x can be split up into two different fractions. It can be as x over x and h over x. X over x is 1 plus h over x. So we're going to be replacing this inside with 1 plus h over x. So I have limit as h approaches 0, ln of 1 plus h over x all over h. Next step is to make a substitution. We're going to let h over x equal 1 over n. So as h approaches 0, h over x also approaches 0. Since h goes to 0 and x is just x, 0 over x is 0. So h over x goes to 0. That means 1 over n also has to go to 0, since they're equal. So 1 over n also has to go to 0. And that's true when n goes to infinity. Here we're going to go to positive infinity because we're looking at natural log, and natural log is defined for x being greater than 0. So it doesn't make sense to go to negative infinity. So the domain is from 0 to infinity. Okay, so we're going to rewrite this now. We're going to change h over x to be 1 over n. H, well, in order to find h, I need to multiply x, both sides of this equation, to get, h is equal to x over n. So this will be replaced with x over n. So let's write that down. I have limit as n approaches infinity, ln of 1 plus 1 over n divided by x over n. Sorry, we need to switch this. So this is n approaching infinity. Right, so that's what we said over here. So that's n approaching infinity. Okay. Because we're dividing by x over n, that's the same thing as multiplying by the reciprocal, which is n over x. So we can rewrite this thing as n over x times natural log 1 plus 1 over n. The x can be factored out because it does not depend on n. So it's kind of like a constant in this case. And it's going to come as 1 over x because x is in the denominator. And another thing is we need to review the property for exponents for using natural log. So if we have the case where it's k times natural log of x, the k comes as the exponent of x. In this case, the n plays a role of k, So this n is going to be the exponent of 1 plus 1 over n. So I'm left with 1 over x times limit as n approaches infinity of natural log 1 plus 1 over n raised to the n. So just to be clear, the n is only inside the 1 plus 1 over n. It's not on the natural log. Okay, the next property that we need for logs is whenever we have a situation where we have limit as x approaches some point a, let's say, of a composition of two functions, let's say f of g of x. If f is continuous, we can pull out f. So we can say f of limit as x approaches a of g of x. So we can pull out the f and compose it with a limit of g of x. In this case, 1 plus 1 over n to the n is going to be our g of x, and then f of x is going to be our natural log of x. In this case, actually g of n, since we have it depending on n instead of x. So I'm going to pull out the f of x, which is the natural log. And here, natural log is continuous when n approaches infinity, so we can pull it out. We have 1 over x, and then times the natural log of limit as n approaches infinity of 1 plus 1 over n to the n. The limit, this thing right here, is just e. So that's a famous limit. And so we have 1 over x times ln of e, which is just 1 over x, since the natural log of e is 1. So what we just proved is that the derivative of natural log of x is 1 over x. The next question you might be asking is, what if we had a different base? Right, because for natural log of x, we know that the base is e. So we can rewrite it as log base e of x. So in this case, if we were to do the proof, let's say with log base b of x, the proof would be very similar. The only difference would be in this step right here. So instead we would have 1 over x times log base b. So that's the only thing that changes. And I should also add that whenever you see a natural log, you would replace it with log base b. Okay. So starting with the beginning here, everywhere you see natural log, you just replace it with log base b and leave everything else the same. Okay, so there's quite a few places where you have to do that, but the math doesn't really change. Okay, so we have log base b of limit as n approaches infinity of 1 plus 1 over n. So that's 1 over x times log base b. And we said that the limit as n approaches infinity of 1 plus 1 over n goes to e. So we can write that as log base b of e. And now we can rewrite this. So we can use a change of base formula. So if, let's say, we're given log base a of b, we can rewrite it as a new base, let's say c of b over log base c of a. In this case, we can use base e. So can rewrite this as 1 over x times log base e of e over log base e of b, which log base e of v is just 1 over log base e of b. Well, log base e is just natural log, so you just have natural log b, and so we can rewrite this as 1 over natural log of b times x, and that would be the derivative of log base b of x.